Okay, let's start. Morning, everyone. My name is Wang Liang. I'm an engineer from Baidu. Welcome to Xi'an. So last time I was here was like 20 years ago when I was doing my undergraduate study. So it has been a long time. And last time I was in a Baidu autonomous driving workshop was actually 2 years ago in LA, CVPR 2019. And I remember at that workshop I first introduced the Apollo Light. So you just saw the video that it's a pure vision-based level 4 solution, autonomous driving solution. At that time, we just have the system ready and has the vehicle on the road, started road testing. And for today, Apollo Light itself has been tested over 40,000 kilometers already. So time goes fast and technology also changes very fast. So today, our workshop, the title is Apollo Towards Fully Self-Driving System Approach and Practice. So this year, we made a lot of progress that we want to share with you guys. A very big milestone is that we actually, in certain area in Beijing, we removed the safety driver in the front seat and opened the robotaxi service to the public. Actually, people can use Baidu app, Baidu Map, Baidu D2 app, and to has the robotaxi and experience it in certain area. So also I was also surprised, and you can see this number. I would not. So Baidu is a leading company in autonomous driving in China, and there's some good numbers to share. I was surprised that 3 months ago, the number of developers, Apollo open source platform developers was actually 55,000, and this morning, so the number was changed and already increased by 10,000 just in 3 months. So it's very surprising. Okay, so today we have very. So the workshop is about half day, and we have 6 invited speakers from Baidu to give like 6 topics to the public. And the first one, let me introduce. The first one is Dr. Jun Wang. He's a principal architect in Baidu, and now he's responsible for the visual sensing team, like the Apollo Light project. The second speaker is Dr. Guowei Wan. Guowei is senior tech lead, senior architect in Baidu, and he's the tech lead of localization and mapping. And today he has some very advanced, very hardcore technology to share. Use learning-based approach to do large-scale localization in the city. And the third speaker is Qi Luo. He's a senior architect of planning and control. He's now in the US. Cannot make it here today, but he has a very cool talk and the video and showing to you guys. And the fourth speaker is Mr. Kuang Hu. And Kuang is the tech lead of the Apollo open source platform, and he will introduce the latest progress about this Apollo platform. And that's me, Liang, and I'm responsible for the level 4 technology in Baidu. And today I will talk something about actually about safety, security, and how we move the front seat driver and what's behind that. And the last one is Mr. Yufei Chang. He's the CEO of WhaleDynamic, and also is an Apollo developer. His company has used our platform a lot, and he'll share his experience of using Apollo to you guys. And okay, let's start.
All right, guys, final session, yeah? So it's my honor and my privilege to be here to present what our company has done so far. And because Apollo has provides a tremendous accessibility to global developers, and WhaleDynamic, as a company, we have done so many, I can't safely replace, but supplement to the Apollo ecosystem. Right, so what we have done so far, we have done the sensor fusion kit, and a control-by-wire chassis, and also autonomous driving computing platform, and more importantly, at the end, is the mapping and the localization toolchain for our developer. So, as you can see, that we're facing many problems with developer. So, normally the sensor fusion kit on top of the vehicle is prematurely or awkwardly designed. So actually, if you check out all the designs, some of these from the top-notch company, even that is still with random design and low accuracy, and hard to collaborate, and eventually, you get the bad perception result. And as a product, it's vulnerable to bad weather. And if you open up the trunk, you're going to see a very messy arrangement. All the computing and the networking and the cable are poorly managed, so we're going to solve that problem. So this is our product, level 4 robotaxi sensor fusion kit on top of the vehicle. So it's a robotaxi level, and it's fully Apollo ready. So basically, the developer can just get in and connect to the Apollo, and we have done most of the adaptation work. And we have replaced the perception part to our proprietary design, which is early stage fusion. I'm going to mention that shortly. And more importantly, it's all sensor friendly. So you can replace the sensor from major brands like Oster, WhaleDynamic, Novotel, or whatever the brands you have. Yeah, it's a picture of it. Yeah, that's a side view. So this part shows how we designed that thing. We consider many key points like camera FOV, lidar position as a major concern. And I think my previous colleague just mentioned that the dust and the rain is actually a major concern for the road testing. So we put micro nozzle on top of it, so it can blow away the dust and dirt. And also, if you check out, we have a ventilation part. So we considered the thermal and the ventilation. And we have done the cable management. So it's a unibody, single wire connection to your IPC. And more importantly, installation friendly. So next one, this one is actually open up to all developer. We call it the educational kit. As you may discover that we have so many camera and radar mounts. This is actually to facilitate our developer to have more options to put the camera on. So you don't have to change the FOV of the camera or consider how to put the camera for different angles. We have done the work for you. And also, it's Apollo ready. Early stage fusion, cable management, we have done that. And luckily we opened that to all developers. So the design file is open sourced. So if anyone is interested in our product, just give a shout to Apollo system, ecosystem, and you can get the design file. Yeah, it's robotaxi level and the educational kit, they put it together, and you can check out they are basically the same design, but with different outlet. Yeah, the side view. Yeah, we have used very advanced industrial design software, so we considered all the angles, the FOV, and also the dust and rain protection, thermal ventilation, cable management, etc., etc. So why we call it early stage fusion? I think the previous speaker just mentioned that. I have to echo them again. The LiDAR and camera is not competing. It's not a zero-sum competition. LiDAR itself is to further facilitate the video perception result. We're using the technology called early stage fusion, which means that we combine the RBG channel with LiDAR. So we have a 7 dimensions network. It's the RBG plus XYZI, because LiDAR has the data XYZI, and the camera has the RBG. So we combine them together and pump them into a huge convolution neural network and get a result. So it's RBG point cloud. So to achieve this, you have to build a well-designed, solid fusion box. So this is a hardware trigger, okay? If you understand the spatial temporal synchronization, let me simplify that. It's time synchronization. So importantly, you have to synchronize the camera with the LiDAR and also with the GNSS and the IMU. You have to get the time from the GNSS receiver and shout to like a speaker shout to all the other sensors. So we have the time synchronization at the same time. The LiDAR and the camera may have the exact perception result. Next, So for the sensor fusion box, what's inside? We have done the power management, so you don't have to worry about the power for each sensor, and the cable management as well. So it's a unibody. Everything just connects to the box, and we get a single wire out to the IPC. And a data compression. So it's a 10 gigabyte server, actually. You don't have to worry about how we connect all the Ethernet to the IPC. We have done the server work. And next is the time synchronization. As I just mentioned, the time is from the IMU and GNSS. So we call the early stage fusion box. Yeah, zoom up. So the final product's like that. For the past 2 years, we have done massive testing and tuning work for the hardware and also for the early stage fusion for many companies and the institutions and universities. And this is on-site testing. So next part is the control by wire chassis. I think Kwang just mentioned that Apollo is very open. It's open to all the tier 1 maker and automobile makers. So they may have the control by wire chassis for developer. And we step a little bit forward. So we help the Apollo system to do the adaptation to the control by wire, both passenger and non-passenger vehicle. And we have done the connection, and also we going to release the DBC file. The DBC file actually is a protocol you talk with the chassis. We open that to our developer. So actually, that's our core product. We just unveiled that thing in last month, the Shanghai Auto Show. So it's a fully autonomous delivery vehicle. We have both the commercial version and the education version. So the commercial version is we use for the fully autonomous, level 4 fully autonomous delivery. And the education version is we release to our developer to let them play with it. So the both commercial and educational version. So we put a seat and a control wheel on the chassis. So you don't have to worry about if you cannot get control of the remote. You can sit on side and control the vehicle manually. Next thing, I think most of the developers must be very familiar with this one. This is the previous generation IPC. They have many problems with it, like the lack of PCIe expansibility, thermal ventilation problem, or the power is not supported fully DC-DC or AC-DC. So we cooperate with our partner. We have the new design of the IPC. We consider the thermal ventilation. We consider the PCIe expansibility, so we can have more PCIe board, like a GPU. You can have a dual GPU on site. You can have a CAN card. You can have a 10 gigabyte network card. And it also support DC-DC and AC-DC dual power input. But the next one, that's the big thing, actually. We designed for autonomous driving, more specifically. It's a tandem structure. So we have a better shock absorption and installation friendly to the vehicle. And compared with the conventional design, because usually we have the PCB board, which is vertically connected. So you may have the rigid-to-rigid connection. So once the vehicle is in a driving status, it's poorly react to the shock. The shock absorption is very poor. So we modify that and we optimize the design. And why we say this thing is built for autonomous driving? Because we have a 10 gigabyte network connection, and the CAN card was built on it, and then 5G enabled. So next one, many developers have just asked me how to do the mapping and the localization, because actually that's another core part of the Apollo ecosystem. And we have done the toolchain for our developer. So basically, it's a SaaS service. If you can just simply come to us, and we're going to provide it from the hardware to eventually the semantic map for you. So there are 4 parts of this service. The hardware, the mapping, the PCD generating, and eventually semantic labeling. So that picture is the semantic labeling, and that one is the PCD file. So this is a short video, how we generate the point cloud file. You can check out the detail, the topology, and you can even see the traffic light. Let us zoom in a bit. You can even see the traffic light and trees and signage on top of the road. And that's going to benefit when we do the annotation and labeling. You see the detail? You see the traffic light here, which means the PCB matching is very good. You see all the details. You can even see the pedestrian or the turning corner, or the bushes, or the pylon, traffic lights, which benefit us for do the semantic annotation. So that's a quick view of how we do the online large area mapping generation. So if you have the PCD file and you don't know how to generate a map, you can simply just drop it to us. We give you an online shortcut, and we're going to generate a map for you. This is a mimic of how we generate a PCD file, the topology of the road. You see, it's a fully finished topology. It's based on LiDAR mapping. The next one is a customized fusion visualizer. Why we call it a fusion visualizer? Because it both shows the semantic of the map, and also I'm going to show you shortly about the perception result. We can put the perception result on top of it. So on that picture, you can show the all the detail of the semantic. We labeled the lane, the zebra line, etc. So yeah, that's a video shows what I've done so far. So on that visualizer, you can see all the jiggling stuff. That's the static obstacle. Because normally the visualizer doesn't show the statical visualizer. And this is industrial level or robotaxi level. So for most of the top-notch company, like Waymo or Zoox or other company, they all have this visualizer. I think Apollo gonna have it shortly as well. So we precisely position all these static obstacles, vehicle, the traffic lights here. If you check out the traffic lights, it's lightning. And also, we have an indicator here. Right, so the conclusion. So we have done so many things to Apollo ecosystem, from the sensor fusion kit and the fusion box, early stage fusion. We're gonna release it shortly. It's not replacing the Apollo perception, but to further supplement the perception part and give our developer another option to do the testing. And ultra high performance IPC, we're gonna release it shortly. It controlled by wire chassis for both passenger and non-passenger vehicle. And MSF localization. It's a tool chain, it's not a product. We help our developer do the mapping and the localization based on our mapping tool. And finally, is what we just showed, industrial leveled visualizer. And I think that's all. Thank you for following us. And any question? Don't be hesitant. You can ask me in Chinese. I'm gonna do the interpretation work. I think that's all.